So far we've learned how to do truth tables for 6 things, 6 of these logical operators, but here's the 5 most important ones: the not, the and, the or, the conditional, and the biconditional. In this video, I'll show you how you can create truth tables for more complex truth sentences. So in this question, they're telling us the given is P is true and Q is false. Given P and also given not Q. And they want to know what's the truth value of P implies Q or not P. And the way you can do this, I think the easiest way to do it is just to change the P's and Q's into T's and F's. So since P is true, this P can be a T. And since Q is false, that Q can turn into an F. And since P is true, not P is false. So it turns into this first. And now, kind of like order of operations, we do the parentheses first. So T implies F. That's the one case in the conditional that becomes false. You know, a decent way to do this, actually, is to write underneath the symbol itself. So everything else gets copied. And now false or false is false. I'll put it underneath this symbol. So I simplify this all the way down. So the truth value of this compound sentence is just false. Now that was the truth value of that statement, that complex statement, with a given P, given P and not Q. So you're told that P is true and Q is false. But sometimes they want the entire truth table, which means all possibilities. So if it's a P and a Q, it's going to be a 4-row truth table. The first column is TTFF. The second column is TFTF. That gets us all 4 combinations. Let me just fill in all this. Now, they were nice to you here by giving you all the different columns. Notice how the last column is equal to the thing that I'm trying to find the truth value of for all of the 4 combinations. We'll talk about how you could have created the table with which columns, but in this case, they're giving you all the columns, so it's a lot easier. So you just go one at a time. The P, if P then Q, is only false when you have the T for P and the F. So I say false, and the other 3 are true. Now this one says P and if P then Q. Well, if P then Q is right here. So I'm basically looking at this first column and the third column and looking when are they both true. So they're both true here, and here they're not both true, and the other 2, they're also not both true. And then finally, we look at this. Notice how we have an if-then, and Q is the conclusion. And this thing, which is actually what we just figured out, is the hypothesis. So we're looking for ones. The only time that's going to be false is if the first thing is true and the second thing is false. So here I have to kind of look. I'm looking at this row, this column, and this column, but even though this column's on the right, it's on the left of the expression. So TT is that, FF is true, F to T, that's okay, true. The only one that would give me a false if there was a true in this column and a false in that column, but that didn't happen at all. So at the end, it became just true, 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 true. If something is always true, it's called a tautology. So in this case, because the entire column became trues, the answer is yes. And it means this complicated thing is always true no matter what P and Q are. Now the last thing I'm going to show you is how to create the truth table with the columns if all you have is sort of what the last column is going to be. So first notice there's P's and Q's, so we know there's going to be at least the two columns for P and Q plus a third column for the answer. So I can actually true, might as well, going to have to write them in eventually, so might as well do it now. Now, this whole thing is going to be in the last column. Put the brackets and everything. Now notice how this has its two parts. It has a Q, which there already is a row for that. Then you have this thing. So we're going to need a column for this thing on the left there. So I'm just going to P and not P or Q. Now that has two pieces to it. It has a P and it has a not P or Q. So P already has a column for it, so I need a not P or Q column. And I hope you can see not P or Q means I'm going to need a P or Q column so that I can do the not of it as the next. So that's how I create that's one way of creating the columns. You could also work from the inside out, like I'm going to need a P or Q, and you could create these columns from left to right, but I have created the columns at least, and now I go through it. P or Q is only P or Q is true unless they're both false. Not P or Q is just the opposite of the column I just made. P and not is taking this first column and the one I just made and seeing is there any place where they're both true, and I don't see that. TF, TF, FF, FT. And then finally, this implies that. So I'm looking for, are there any times where there's a T in this big column and an F in this column? Well, there are no T's there, so this is all true. And because they're all true, we say yes, it is a tautology. Just to say one quick thing about tautology, the most basic tautology is P or not P. Like no matter what, that thing is true. That's like what a tautology is, a statement that's always true. So that's how that works.